So the purpose of this experiment was to calculate the concentration of capsaicin found in red Tabasco by using high-performance liquid chromatography. With the HPLC, using a C18 column that has reverse phase, which separates or which elutes the more polar compounds first, we were able to separate the capsaicin and the dihydrocapsaicin. In this instance, the capsaicin is more polar than the dihydrocapsaicin, therefore the capsaicin will elute first. We started by generating two stocks, one of capsaicin solution, which was a 1 milligram per milliliter of capsaicin and ethanol, and the other one of 1 milligram per milliliter of dihydrocapsaicin and ethanol. We created a combination of these two stocks and we ran it through the column 3 times using 3 different mobile phase compositions in order to find the ideal composition for the instrument. The first one was 100% water, which gave us only one peak, which suggested that the capsaicin and the dihydrocapsaicin co-eluted, meaning that they were not successfully separated. The next one, 50% methanol and 50% water, the peaks begin to separate, but they're not, the capsaicin and dihydrocapsaicin weren't fully separated. On this next one, the water, 100% methanol, no water, the peaks are definitely more separated. However, they're not all the way, but we were able to conclude that we need more methanol than water in our mobile phase composition. So we did an optimization by doing 4 more runs with different percentages of methanol, and we calculated the resolution of each of the 2 peaks for these percentages or these compositions, and we were able to find that the ideal composition for the mobile phase in this experiment would be 70% methanol and 30% water. Next, we aim to find the ideal flow rate, and we did this by testing various flow rates and calculating the height at these flow rates, and the height with the lowest value, or the flow rate with the lowest height value, would be the ideal flow rate, which in this case would be 1.2 milliliters per minute. And this is because it has the highest number of theoretical plates. We then diluted the capsaicin standard by a factor of 2, 5, 10, 20, and 50. And we obtained the chromatogram for each of these dilutions. And we also have the unknown plotted in this chromatogram. And here's the capsaicin and dihydrocapsaicin peaks labeled. With this chromatogram, we're able to do a calibration curve where we plotted peak height of the capsaicin versus the concentration of the capsaicin and in the standard. So with this, we obtained this equation shown down here that will allow us to calculate the concentration of capsaicin in the unknown sample. And the linear fit had an R squared of 0.996, which indicated a good fit for the model line data. So then here's the chromatogram of the unknown that we obtained, and the capsaicin showed a peak of about 200 with an uncertainty of 12, and we plugged this 200 into the Y value of our equation obtained by the calibration curve, and we solved for X to obtain the concentration. Taking into account all the dilution factors, we got a total of 1.27 milligrams per gram of red Tabasco, milligrams of capsaicin per gram of Tabasco sauce. And this had an uncertainty of 0.05. And we were able to convert this to Scoville units by simply multiplying by 16 million, which resulted in 20,300 Scovilles with a 900 Scoville uncertainty.